question on displacement. Yeah, it's a question on displacement, speed, and acceleration. So we are talking of, we are given an expression here of a certain particle that was moving maybe along a straight line or in a given direction. So we are going to get the distance moved during the second second. So what we're gonna do is very easy. We have this expression. So we're going to say, we start with A, we're going to say distance covered in first second will be equal to, we are going to substitute the value of Ts as 1. So we're going to say S is the same as 7 plus 8 into 1 squared minus 2 into 1 cubed. This one is 7 plus 8 minus 2. So we're going to have, this is 13, this is 13 meters. That's the distance covered in the first second. Now, again, we get the distance covered in the second second. So again, we substitute the value of t as 2. So we are going to substitute again in the equation. So we are going to have s is equal to, we're substituting actually in the original equation. Right? So s should be the same as 7 plus 8. The value of t is 2 squared minus 2. The value of t is 2 cubed. So are you together at that point? Right? Let's proceed. So we have 7 plus, this is 8 times 4 is that's 2. That's 2 minus, this is 8 times 2 is 16. So this one is going to give me, this is 7. So this is that 9 minus 16. We're going to have 23 meters. So if there is no equation at that point, we can finally get our answer here. So remember, please remember the question asks the distance moved during the second or during the second second. We are not asked the distance covered after 2 seconds. It is the distance moved during the second or during the second second. So we are going to take 23, we minus 13. We get 10 meters. You can comfortably write the A and S. Now, the second question is asking about acceleration attained at the end of the 4th second. So like I said, this one is a question on displacement, speed and acceleration. In other words, it's a question from differentiation. So what we're going to do, when we are given the displacement function, we are required to differentiate that function to give us speed. Then from there, we differentiate speed with respect to time. We are going to get what we call acceleration. So we are going to write this. So we get what we call, so we say ds over dt. So we are differentiating distance with respect to time to get the expression for speed. ds over dt should be equal to, this one is a constant, 7 is a constant. So we are going to have, we bring this power down here. So we are going to have 2, we can just have the equation here, t7 plus 8t squared minus 2t cubed. So this is how we go about it. So this one is a constant, so you can just forget about it a bit. So we're going to have this and bring this power here. So it becomes 2, yeah? It becomes 2 times 8. That one gives me 16. T. Then again to this power, we minus 1. Minus 1 there. So 2 minus 1 is 1. So t raised to power 1 is t. So you have 16t minus. Then you take the other power here. This power you bring it down here. So you're going to have 3 times 2, you get 6t. Then to that power again, 3 minus 1. So we're going to have 60 squared. So this one is called the first order derivative. First order derivative. So that one is the expression for speed. You are about to get the speed or velocity, like it. So from there, we're going to get the second order derivative so that we can be able to get the expression for acceleration. So we differentiate again, we differentiate speed in respect to time. So we are differentiating speed with respect to time. So that's why the S is squared. So we're going to have, we differentiate this expression again. So this one will remain 16. Remember, this one is raised to power 1. So power 1 minus 1 is 0. Any number is power 0 is 1. Yeah, so we are going to have 16 times 1, which is 16 minus. Then we have, you bring this one down here. We're going to have 2 times 6 is 12t. Raised to power, here 2, where you have 2, we minus 1, the power will remain 1. So it will be raised to power 1, which is the same, simply that one. So the expression for acceleration is 16 minus 12t. Then from there, we substitute the values to get the final answer. We are told the acceleration attained at the end of the 4th second. So we're going to have, you can comfortably say acceleration is equal to 16 minus 12. The time is 4. T is 4. We're going to have 16 minus, this is 48. We're going to have negative 92 meters per second squared. My friend, that is the beauty of